Have you ever stopped to wonder what's actually going on when milk goes sour? Or when you crack an egg into a hot pan and watch it turn solid? These aren't just random, everyday things that happen. Nope. They're chemistry in action. They're all chemical reactions, and we're about to break down exactly what that means.
So let's just start with this question. What could sour milk, a rusty old pan, and cooking your dinner possibly have in common? On the surface, they seem totally unrelated, right? But they all share one fundamental secret. Every single one of them is a chemical reaction.
And this is that secret. A chemical reaction is basically a process that takes one set of substances and transforms them into something completely, and I mean completely, new. Now don't get this confused with a physical change, like ice melting into water, because that's still just H2O, right? A chemical reaction is way deeper. It literally breaks the bonds between atoms and rearranges them to build entirely new stuff with totally different properties. That sour milk, it isn't just milk that tastes funny. Its actual chemical makeup has changed forever.
Okay, so that's the big idea. But how can you actually see this stuff happening? How can you become a chemistry detective right in your own kitchen or backyard and spot these transformations when they occur? Well, turns out there are some classic clues to look for.
And here it is, your official detective's toolkit. We're going to walk through 5 telltale signs that a chemical reaction is going down. And trust me, once you know what to look for, you are going to start seeing chemistry absolutely everywhere.
So, the 5 key clues are a change in state or color, suddenly seeing gas or bubbles, a shift in temperature, either hot or cold, and the formation of a solid that we call a precipitate. Let's zoom in on those last 2, because they're pretty cool.
All right, a change in temperature. This is where it gets really interesting. Some reactions, we call them exothermic, actually release energy as they happen. A perfect example is respiration, the process happening in your body right now. It's like a slow, controlled burn that releases energy from your food to keep you warm. Then you have the opposite, endothermic reactions, which absorb energy from their surroundings, making things feel cold. A lot of decomposition reactions work just like this. So here's the key takeaway. If something gets hot or cold all by itself, you're almost certainly looking at a chemical reaction.
And what about that last clue, a precipitate? Now this one sounds a little technical, but it's one of the most visual clues you can get. Just imagine, you mix 2 perfectly clear liquids together, and poof! All of a sudden a cloudy solid appears out of nowhere and starts to drift down. That solid is the precipitate. It's an amazing sign that a brand new substance, one that can't dissolve in the liquid, was just created right before your very eyes.
So, now we know how to spot these reactions. But how do scientists actually talk about them? How do they write them down in a way that makes sense? Well, they use a kind of shorthand. Think of it like a recipe for the change that's happening. And that recipe is called a chemical equation. It's basically the universal language that chemists use to describe exactly what's going on. And it's more than just a description. It's a super powerful tool that lets scientists understand, predict, and even control the chemical world all around us. Let's see how this actually works. We can start simple with a word equation. For example, when the element magnesium burns, it combines with oxygen from the air to create a new white powder, magnesium oxide. Simple enough, right? But to make it really useful, chemists swap out the words for their chemical formulas. So magnesium becomes Mg, oxygen becomes O2, and magnesium oxide becomes MgO. And that's called a skeletal equation. Now, in this new language, we have some specific terms we need to know. The starting ingredients, in this case are magnesium and oxygen, are called the reactants. And here's the golden rule you got to remember. The reactants are always written on the left-hand side of that arrow before the change happens. The arrow itself means yields or produces. It points toward the new stuff that gets made. So there you have it. You can now spot a reaction and you can read its basic recipe. But take a closer look at that last equation for magnesium oxide. See, there's a sneaky little problem hiding in there. It's not balanced. And that's a big deal because it breaks a fundamental law of the entire universe. What that law is and how we fix the recipe to obey it, well, that's the next critical step in mastering the language of chemistry.